In this tutorial, we will learn how we can create a PDF sorter application. But before I give you the demo of this application, let me give you a background why we need to create this application. What is the need for this PDF sorter application? So if I open a new tab and write YOLO V7 paper, and here you can see we have the first link, and I just click on view PDF from here, and I download this paper simply. So I will just save this paper over here. Okay, that looks fine. And in the same way, I write YOLO V9 paper over here and just open this first link, view PDF. Okay. And okay, so if I just click on download from here, so I'm now downloading YOLO V9 paper. And if I just write YOLO V10 paper over here, YOLO V10 is the latest object detection model. So that so I'm downloading these different object detection models papers. Okay, and so now I've downloaded YOLO V10 paper over here. Okay, that looks fine. So if I just go over here, so now you can see these are the three different papers. Like I've downloaded YOLO V7, YOLO V9, and YOLO V10 paper. But you can see that any of these papers or these files do not have any name. Like they do not have any organized pattern. So if I want to open YOLO V7 paper, I don't know which one it is. Like I don't know whether this one is a YOLO V7 paper or this one is the YOLO V7 paper, because they do not have any name and they do not have any organized pattern. Okay, so if we have 100 of such documents over here, like if I have 100 of such research papers, and if I want to open YOLO V9 paper, it will be impossible for me to open it by seeing the file name over here. So I need to open each of the PDF files, and I need to look like whether this is the YOLO, this contains a YOLO V9 paper or no. So if we have 100 of such documents, it will become impossible for me to randomly open a file and we can say that this is a YOLO V9 paper. I need to open each of the PDF file and I need to search for the YOLO V9 paper among all these hundreds of PDF files. But so currently you can see they do not have any organized pattern, but we can organize this PDF file and we can use AI to organize this PDF file. So what we can do is we can rename these files with the title of the paper, and we can add some keywords that we have in the paper, or we can also add author names in the file name as well. So as you know that in the file name, there is a limit, like the file name can be these words long or these characters long. So considering this limit, we will update all these file names with the help of AI. We will organize this PDF and we will add the title of the research papers in as the file name, and we will also add some keywords in the paper and as the file name as well. So then it will be easy for us to, with the as the title of the paper with the file name, so we can easily open any YOLO V9, YOLO V7, or YOLO V10 papers. Okay. So let me show you how we can do this with the help of AI. So let me just go here. So let me just close this up and let me just upload some of the files over here that we have downloaded. So if you can see over here, I will upload all these three files over here, and I will just click on organize PDF buttons. Okay, so now it will work on PDF. So the PDF number 1 will have now this name, YOLO V7 trainable bag of freebies. PDF 2 will have this name, YOLO V9 learning what you will want to learn using programmable gradient information. So the title of this paper are now are the file names. Okay, and PDF 3 will have this name, YOLO V10 real-time end-to-end object detection. Okay, so let me show you these three PDF files. Now let me show you how these PDF looked like after we organize these PDFs. Okay. So now you can see over here, these are my organized PDFs. So now you can see the title of the paper are the file names over here. And so now if I want to open YOLO V7 paper, I can see that over here, YOLO V7 is written, and I can easily figure out that this is the YOLO V7 paper. And if I open it, you can see This is a YOLO V7 paper, YOLO V7 trainable bag of freebies, set new state of the art for real-time object detectors. And you can see this is the title of name of the paper as well, or the file name. And if I want to open YOLO V9 research paper, and you can see this is a YOLO V9, learning what you want to learn using programmable gradient information. So the title of the paper is the file name over here, and you can see these are the some keywords that are detected from that are gathered from this paper, like deep learning object detection, gradient information. So you can see that some keywords like gradient information, because gradient information technique is being used in YOLO V9, and here you can see we have the YOLO V10 paper. So the title of the paper is the file name YOLO V10 real-time end-to-end object detection. So YOLO V10 real-time end-to-end object detection is the title of the paper, and it is now the file name. And plus you can see object detection, real-time detection, and computer vision are the keywords that help us to find out the relevant paper. Okay, so this is a quick demo of the application that we will be building in this tutorial. So let's start writing down the code.
Before we go ahead, I want to show you one thing. We have different computer vision and generative AI courses available on Udemy platform. The price of these courses is between $10 to $13. You can check out the content of these courses, and if you find out these courses helpful, you can buy out this course, and this will be a great support for me, and it will motivate me to continue producing computer vision and generative AI content. We have 10 different courses available on Udemy platform, and we have got very good reviews from our students who have enrolled into these courses. You can check out student reviews below as well. And if any course, if you find any course content helpful, you can buy out this course, and this will be a great support for me. So we have 10 different courses available on Udemy platform. Do check out these courses. The link of all these courses are provided in the description of this video. You can check out these courses. Thank you.
The code. So I have created a project in PyCharm. So first of all, I will create a requirements.txt file, and I will install all the required packages over here. So I will just create a requirements.txt file. So we require a Streamlit package. We require LangChain-Graph because we will be using Llama 3.1 model. And for Llama, to access the Llama 3.1 model through API, we will be using Grok service. And as we are creating web UI using Streamlit, so we will be using the Streamlit package as well. And to set up our environment, we require python-dot environment. And to extract the data from the PDF file, we require PyPDF package. Okay, so I will just install these 4 packages first. So I will right click install my -r requirements.txt. So now I will install all the packages that are listed in the requirement.txt file. So as we are creating a web UI using Streamlit, so we require Streamlit package. And as we are accessing Llama 3.1 model through API, so we will be using third-party service Grok. So we'll install LangChain-Graph package, and we are using python-.env to set up our environment. So this package is required because we will be using this library to set up our environment. And then we want to extract the data from the PDF file. So we require the PyPDF package. Okay. So now we will just set .env file where I will just pass my Grok API key over here. Okay, and then I will just create a main.py file, and I will start writing down the code over here. Okay, so in the main.py file, I will just write down all my code. So in the meanwhile, all these packages get installed. Let's import all the required libraries, and let's start writing down our code. So we require import OS, import Streamlit as st from dot environment import so that we can set up our environment env, and from LangChain dash raw or chat rock so that we can use Llama 3.1 model and we can chat with our Llama 3.1 model. And from PyPDF, so we need to extract the data from PDF file. So for PyPDF reader. And we need to remove the metadata from our output response. For that, we will import LangChain.core-output parsers, import string output parser. Okay, so we require this library so that we can remove the metadata from our response. What we are getting over here. Let's talk about this later on. So now we'll set up the environment. So we will write lower dash dot environment so that we can set up our environment. And let's first initialize and load the Llama 3.1 model. So we have to write lm is equal to chat rock model is equal to. So we will be using Llama 3.1 model with 70 billion parameters. So first I will show you how we can extract text from PDF files. So first I will just create a folder over here by the name folder directory over here by the name PDFs, and it will contain all the PDFs. And then I will just create another directory which organized, which will contain the PDF in the organized format. Okay. So now in the PDF directory, I will add all the 3 PDF. So let me do this. So now you can see in the PDF directory, I've added all the 3 PDFs and it looks good. Okay. And in the organized directory, we will have the PDFs in the organized format, and the file name of the PDF will be the title of the paper and with some keywords as well. Okay. So now we need to extract data from this PDF. So we'll just provide you an example. So inside PDF. So I will just extract data from this PDF file. So we have PDF reader, and I will just pass the file path over here. So let's see how much number of pages we have in this PDF file. And now we write number of pages. Okay. So let's run this script. So let's see how many pages we have inside this PDF file. We have 15 number of pages inside this PDF file. So if we want to read the data of page number 1, which is basically 0 over here, we'll write print page. So let's see if we are able to read or extract data from this page number 1 or not. I think here we should have pages. So now you can see there is some vector data. We need to extract the data. So what we can do over here is I will write page dot extract dash text. Okay, and let's see if we are able to extract the text from the page number 1 or not. So yes, we are able to extract data from this PDF page number 1. Okay. So YOLO C7 trainable bag of freebies sets new state of the art for real-time object detection. And you can see this is the data we have extracted from this PDF page number 1. Okay. So that looks good. Okay, so in this way, we can extract data from this PDF. And if now you can see the length of number of the pages were 14. Okay, so if I just want number of pages were 15. Okay, so if you want to extract the data for the last page, page number 15, I will just write 14 over here. And let's see if we are able to extract the data from the last page. Okay, so now you can see we are able to extract the data from the last page, page number 15. And if I just write page 15, number 15 over here, it will say that index exceeded. So index out of range. So we can extract data from 0 to 14, which is 1 to 15 pages. Okay. So you can just use this example and extract data from any of the page. So now we'll continue and create a Streamlit application. So start right page dash config, page dash title, PDF sorter is our application which we are creating in this tutorial. The title will be PDF sorter. So we need to upload the PDFs, and then the output will be the PDFs in the organized format. st.file dash uploader. Upload your files. So we want to upload PDF file so that we can only upload the PDF files, and it can accept multiple files as well. So once the user uploads the file, so let's see in the meanwhile how it works. So I will just write Streamlit run main.py. So now let's see if we are able to upload these files. So now you can see we are able to upload multiple files. So it works well till now. Let's write down the rest of the code. So now first we'll create a button if st.button organize PDFs. So once the user click on the organize PDF button, then we will carry a spinner which will be working on PDFs. So now we'll write for I, file in, enumerate files. So the title of the paper is always in the first page. So we will just read the first page for each of the files that the user has uploaded. Like if the user have uploaded 10 files, we will read the first page of all those files. Okay. So we can also find the number of pages. Then pages. So as I told you that we need to only read the first page. So we'll add 0 over here because the first page will contain the title, and we can extract the keywords from the first page as well of the document. So now we will extract the text. So this will be raw text. So Let's make it first page. So let's write all the text. Let's print all the text of the first page into our Streamlit application. But organize PDF button is not appearing. Why it's so? Now let me just check it once. So I have just rerun the Streamlit app. Now you can see over here, this organize PDF button is appearing. I don't know what such issue was appearing previously, but just rerunning it makes it works perfect. So now let's see. So now you can see that this is the text of the first page for the YOLO V7 paper. This is the text of the first page for the YOLO V9 paper. Okay, and this is the text of the first page for the YOLO V10 papers. Okay, so we have a lot of these Unicode characters over here. Okay, but we only want the title and some keywords. So this will not be very much issue for us. Okay, so let's get back to Word now. So first we will define a prompt over here. So this will be our input prompt that we will pass to the model. Below is the text of research paper. So the raw text will have the text of the research paper for the first page. Using the text, generate the name of the paper as well as 2 or 3 keywords. Give raw text as the output. Please make sure to follow the following output format. So we need to define the output format first. And we can also write here is the raw text of the research paper. Okay, so the raw text variable will have the raw text. And now we need to define the output format first. We can write input prompt over here, output format. So now here we will define the output format. So in the output format, we will have the title. Then we have the keyword. So we require 3 keywords. So we write keyword. So this is the output format which we will be following. Okay. So let's call the large language model and pass this input prompt. We have defined the large language model over here. Okay, above this. So we can write element invoke prompt. And we need to remove the metadata from the output response. So we write parser.invoke result. Okay, so our output response can have include such characters that we don't want. So we'll just clean our output response. So we are joining without any empty, passing any empty space. C for C in response. So if the C contains alphanumeric or C has empty space, dash, or an underscore. So if our response has alphanumeric characters or they have such empty space or dash or underscores, we will accept this in our response, else we will exclude or remove those from our responses. And we will just create a subheader. So, so this will contain the count as well. So we are just doing the stuff over here. Now we'll just create a text area placeholder and we will just write st.markdown. Save. Okay. So if there is text area, we have defined a text area placeholder. So we'll just write markdown and we can write response plain text. We can simply write unsafe dash allowed out HTML is equal to true. So that looks good. So now after getting the title of those PDF files, like the response will have the title and some keywords of the from the PDF file, and we will display this title and keywords into our Streamlit application. Plus, let's update the file name of the PDFs with those titles and the keywords. And let's save those files as well in the organized folder directory which we have created. So currently you can see we have created a directory by the name organized. But if there is no such directory, we can also create this. Like if you forgot to create an organized directory, you can also create it. So we can write here. Okay. So if the output folder exists, that's okay. But if there doesn't exist, we can create this output directory by the name organized. So our new file path will be and we have in this variable we have the file name plus we also have some keywords. So we have this response clean text. So we'll update the PDF file with this. So now we'll write the uploaded file to a new location. We need to write, so we are writing WB. So we have stored our uploaded file in the studio area files. So we write files because we have stored our uploaded files into the variable files. Okay, so we have written our complete code. Let's review it once. Oh no, we are looping through each of the files. So I will just write file over here. Okay, that looks perfect. So let's run this out now. So I will upload all the three PDFs we have over here, and let's organize those PDFs. So the PDF one will have the title, YOLO V7 trainable bag of freebies, sets new state of the art for real-time object detectors. Your PDF 2 will have YOLO V9 learning what you want to learn using programmable gradient information. So this is the title of the paper, and these three are the keywords that we have extracted from the PDF. And YOLO V10 real-time end-to-end object detection. This is the title of the paper, and these are the three keywords that we have extracted from the paper. And this is the title of the paper of the PDF one, and these three are the keywords. Okay. So let's see if we have in our directory. So if we just open this up now, so you can see in the organized folder, we have these papers now. So now you can see YOLO V7 trainable bag of freebies, and the title of the paper is YOLO V7 trainable bag of freebies. So you can see that the file name is YOLO V7 trainable bag of freebies, and you can see the file name also contain the keywords like object detection, computer vision, deep learning, and you can see this is the YOLO V9 paper, learning what you want to learn using programmable gradient information, and you can see these are the three keywords. So let's open this up and let's see. So now you can see over here, this is a YOLO V9 paper, YOLO V9 learning what you want to learn using programmable gradient information. And if I just open this up, now YOLO V10, and now you can see over here, this is the title, this is a YOLO V10 paper, YOLO V10 real-time end-to-end object detection. So that's look good. And you can see that these three are the keywords. You can also add author names over here. So in this tutorial, we have seen that how we can organize our PDF files using AI, and we have created a PDF sorter application using Streamlit and Llama 3.1 model. So that's all from this tutorial. Thank you for watching.